All right, so we're going to take a look at example 2, but we're going to simplify using the Pythagorean, not theorem, identity. Sorry, guys. I didn't pay attention to that part. Let me change this to identity. All right, now, with this, I give you the sine one. It says sine theta equals 4 over 5, and they want you to find cosecant. I do that right? Cosecant. Sorry, let's just say cosine. Oh, messing up a lot right now in the world. All right, we're doing cosine theta. Find cosine theta. Now, with that, our goal and our idea that should work here is, okay, what trig identities or identity has both sine and cosine in it at the same time. And hopefully you're saying, oh, what's that first one, Mr. Hall? Oh. So yeah, let's use that first one. So cosine squared theta, let's do theta, plus sine squared theta equals 1. And again, don't get bogged down and be like, Mr. Hall, well, I'm confused. Why do you keep using x's and thetas and you keep switching it? I'm switching it because you're going to see the different problems, different books, different websites use theta and use x. So again, make sure you're able to do either one, both of them. All right, so here, cosine is what we're trying to find. So right now we're at cosine squared, but we need to find cosine. So here, one thing I'm going to do, I'm going to rewrite this so that it's sine theta quantity squared. So for each one of these, even for cosine, you can make that as cosine squared. You can make that as cosine quantity squared, sine quantity squared, tangent quantity squared, secant quantity squared, cosecant quantity squared, all that. So it can happen like that. So that way, because the problem, in our problem, we have sine theta. We don't have sine squared theta. We have sine. So we rewrote that so it deals with sine. So let's go for it. Here we're going to do 4 over 5, which is our sine. And we're going to have to solve this out. So we're going to have to do some work here, guys. It's going to be some work. Arithmetic and everything. So let's go for it. So here, the 4 over 5 squared means you squared the 4 and you squared the 5. So 16 over 25. All right, so we're going to have to move that 16 over 25 over to the other side. So I'm going to subtract 16 over 25 from both sides. Again, subtract them. And 1 minus 16 over 25. So we subtract 16 over 25 from both sides. All right, we're going to simplify it down. So this is, guys, this is going to be some work. Remember, whenever we do subtract fractions or subtract whole numbers and all that stuff, you have to have common denominators and everything. So here, in order for us to have a common denominator to be able to subtract these two things, we have to have the same denominator. If the first fraction had a denominator of 25, that means our denominator right here has to be 25. So with this part, we're going to do something over 25 minus 16 over 25. And if you remember what we talked about before, anything over itself is 1. You know that before in the past. If the bottom is 25, to match it with that 25 denominator, the top has to be 25 also. And then we have our cosine squared theta. Simplify this down. 25 minus 16 is 9 over 25. That equals cosine squared theta. And we have to simplify this down by doing the square root. This is squared here, so we square root both sides c. So we're going to get cosine. And there's more work on this about like whether positive or negative. Normally you would have plus or minus the answer. But for right now, we're going to just deal with the positive portion of it in quadrant 1. So that's going to be 3 over 5. So our answer that we're looking for right here is cosine theta equals 3 over 5. Bam. We're good. So let's go to number 2. All right, so then let's go to the next one. And this one now has tangent and secant in it. Should be a little bit easier, hopefully. But with it, again, we're looking at the trig identity that has both tangent and secant inside of it. So let's go with that part. Let's figure out what's going on. All right, so here we know we have, what's it, 1 plus tangent squared theta equals secant squared theta. That's our trig identity. And like on the last problem, guys, we got to the end and we had the square root. We're going to have to do this pretty much every time, square root everything, because we got to get down to the actual nitty gritty, the answer there. All right, so here we have this part. We know what tangent is. We need to find secant. So with that, let's go and change our numbers over here. Not numbers, but our writing over to black. All right, so here we're going to do 1. We're going to make tangent like this, just like we did before. All right, and we know tangent is 5, so we're going to substitute 5 in there. So we're going to do 1 plus 5 squared equals secant squared. All right, we know what 5 squared is, which is 25. So 1 plus 25 equals that secant squared theta. So that's 26 equals secant squared. But remember, again, we don't need secant squared. We need secant. So here, take the square root of both sides again. Square root, square root. And again, we're going to just talk about the first quadrant, which means everything's positive. So we're going to do the square root of 26 equals secant of theta. Again, we're just talking about the first quadrant, so that way we don't have to worry about going more in depth and everything. So a whole lot more of that. Pre-cal will go more in depth with it, though. All right, so let's go to example, the third one, the third part in this example, and then that's it, guys. That's it. So the third and final one deals with our cotangent. Cotangent. All right, so with it, we have cotangent and cosecant, and just like before, again, make sure that you choose the trig identity that has both of them in it. Both of them in it. So here, the one trig identity that actually has both cosecant and cotangent in it is cotangent squared theta plus 1 equals cosecant squared theta. So we're going to do the same thing. Take the cotangents, square it out and everything, and go from there. The part that gets most people is the arithmetic portion of it. So if you are struggling with that, then yeah, you just got to work on it. That's all you can really do. This is 9 over 2 squared plus 1 equals cosecant squared theta. Push that up a little bit. All right, so now this is 81 over 4. All right, and now here, again, we have to have a common denominator to be able to add the 1. So here, that means we'll have to have a 4 for a denominator there. So that way it's same denominators here, common denominators. Oh, is that what I want to do? Common denominators there. All right, so from that part, we know it has to be 1, so we put a 4 on top. So 4 over 4 is 1. All right, and so here, we're going to add that together and then do some work on it. So here, add them up, we get 85 over 4. And again, we have to solve for theta. Not solve for theta, sorry, solve for cosine. Cosecant, that's what we're looking for, cosecant. What is cosecant equal to? All right, so here, take the square root of both sides here. And hopefully you guys remember your rules for square roots. Because here, the square root of 85 does not work out perfectly. So what we're going to do is keep that square root of 85 there, because if you don't, it's going to give you a decimal, and there should be no decimal answers here for this problem. No decimal answers, guys. No decimals. I don't want to see decimals at all for this. If you give me a decimal, it's wrong. Automatically wrong. Even though you did all the work, even though you did all the work correctly, it's wrong. So with that, again, no decimals for any of this stuff. You can like go bypass that and give me decimals, but then they'll be marked wrong, and then you'll be upset and mad and everything. But no decimals. I need to have radicals here. All right. So here we can do square root of 85, and we do square root of 4, which is 2. So remember, our rules of radicals mean that you can actually break it apart, the fraction apart, and actually do the top and the bottom. So that's what we did. And so again, we're talking about quadrant 1. So therefore, everything is going to be positive. If we're talking about quadrant 1, we talk about negatives and positives and all that stuff, but everything's going to be in quadrant 1. All right, cool. So guys, that's it. That's Pythagorean identities. That's like using those identities in stuff. Now, our next lesson is going to actually deal with using Pythagorean identities and using quotient identities and using reciprocal identities to try to verify, simplify, all that great stuff. It won't be as hard as it would be for a pre-calc class, but it's going to give us some a little challenge. So it's going to be great. All right. So we're going to do a practice next and then go from there.